So this is number one on the handout. It says the admissions officer for the graduate programs at SFU believes that the average score on the GRE exam at SFU is significantly higher than the national average of 1,300. Assume that the population standard deviation is 125 and a random sample of 25 scores had an average of 1375. Assume a significance level of 5%. So a couple things, we're going to walk through this, but the first one says state the appropriate null and alternative hypotheses. So that's what we want to do first, and we always start with the alternative because that's what we're trying to prove, and that kind of leads us to the null hypothesis. Not sure what's going on here. There we go. There we go. So the alternative is what in this case? We're trying to prove that the mean is greater than 1,300. That's the national average. So mu is equal to 1,300. And some things I was given in that problem, it says we sampled 25, so I'm going to write that down. We're trying to prove this at 5% significance level. The population standard deviation is 125. And when we took a sample of 25, we got a test statistic of 1375. Those were all given, okay? So A says, state the appropriate null and alternative hypothesis. Done. A is done, okay? B says, excuse me, draw the graph. What kind of tell test I have? Because it is greater than, what kind of tell test? It's a right tell test, right? So let's draw it both in terms of x bar, okay, 1,300, standard deviation's 125. It's a right tell test, alpha is 5%. Let's draw it in terms of z as well. 0, standard deviation 1, 5%. And so we kind of drew the graph, okay, drew both graphs. This is x bar world, this is z world. Okay, so B is done. Then it says set up the rejection region in terms of x bar and z. I have to start with z. Since alpha is 5%, what is my rejection region in terms of z over here? 1.645. Does everyone know where that comes from? There's a little table, 5% to the right, 1.645. Does this make sense? I want to set up my rejection region in terms of x bar, and the formula to do that is x bar lower bound is equal to mean plus z times the standard deviation divided by the square root of n. So let's plug in everything we know. The mean is 1,300. Z is 1.645. The standard deviation is 125. N is 25. We get 1,300 plus 1.645. This comes out to be 125 divided by 5, which is 25. So the lower bound of the rejection region is, let's see, 25 times 1.645 gives me 1341.125. Okay, so if you think about it, that means we're done with part C. We've set up the rejection region in terms of Z and X bar. Does anyone have any questions on those first few steps? All right, very good. It says, D says, compare your test statistic to the rejection region. So here is my test statistic. This is my evidence, and this is the rejection region in terms of X bar. And we can clearly see that it starts at 1375. I'm sorry, it starts at 1341. The evidence is 1375. It's in there. So part E says, what is your conclusion? This is what I'm looking for, either decision 1 or decision 2. What is my conclusion then? Do we have enough evidence? We do. So we're going to make decision 1, which is reject the null in favor of the alternative. Okay, I have enough evidence, right? It's 1341 was the bar. I'm over that bar. I have enough evidence to reject the null in favor of the alternative. F says, and this is maybe where maybe you got a little hairy, it says calculate the p-value. Okay, calculate the p-value. So we know we have enough evidence at the 5% significance level. The p-value is the probability of observing a value at least as extreme as the test statistic computed. The test statistic computed was 1375. So my p-value is the probability that I get a value more extreme than the test statistic, which is 1375. This area is my p-value. Does that make sense? Which part?
About the p-value.
Okay, the p-value, and this is the definition of it, is the probability of observing a value at least as extreme as the test statistic computed. The test statistic that we came up with, the evidence, is 1375. We're saying, hey, what's the odds that we get something greater than that, more extreme than that? Well, I can't find this area because this is a non-standard curve. So what do I need to do to that 1375? Convert it to a z-value using this formula. Z is equal to x bar minus the mean divided by the standard deviation divided by the square root of n. Gives me the probability z is greater than 1375 minus 1300, which is my original mean, divided by 125, which is my standard deviation, divided by the square root of 25, which is my n. Trust me, the math comes out to be the probability that z is greater than 3.0. Okay, so 3.0 is over here. So these things are same. 1375 in the x bar world is 3.0 in the z world. The probability that x bar is greater than 1375, well, let's see. Greater than 3.0. Let's look up 3.0. It comes out to be 0.9987, if you guys can see that. 0.9987. But we're looking for greater than that. So it has to be 1 minus 0.9987, which gives me 0.0013. That is my p-value, right? And now that tells me exactly how much evidence I have. And we want to assign a word to that. What is the word we're going to assign to a p-value that damn small? Yes?
Overwhelming.
Overwhelming evidence. Because it's less than 1%. That's a whole lot of evidence. Overwhelming. If it was between 1% and 5%, we would say strong. If it's between 5% and 10%, we say weak. And if it's greater than 10%, we say we have no evidence. So I would write overwhelming evidence. Okay, and H says, does it confirm the conclusion in part E? The answer to that is yes. And I says, would our conclusion be the same at the 1% significance level? Well, I don't care how you do this, but think about it. At the 1% significance level, I'm saying I need overwhelming evidence. I have overwhelming evidence, so would I still reject the null and favorable alternative? I would, right? Does this make sense? Okay, so you guys, for this little quiz, any questions before I hand out the quiz? You guys are allowed any notes you have. I have some extra Z tables if you need one. Some of you, I've probably given 7 Z tables over the course of this course. But you're allowed open book, open notes. Are you ready? So, first thing, the one you're getting is number 2. Yes, Roger.
If it was like 1375 point something, would it still be in the range or no?
Yes. Any value. Roger asked, he said, if the test statistic was 1375 point something, would it still be in the range? Yeah. Roger, anything greater than 1341 is in the rejection range. So I don't care if it's 1375.8, I don't care if it's 1500, it's in the rejection range. Anything greater than 1341.125. Yes?
Can we use our homework?
Huh?
Can we use our homework? Because I wrote like a couple water problems on mine.
That homework that I did?
Yeah.
That I did on the video that you had to watch?
No, that paper.
Huh?
Yeah, the paper.
Oh, the thing I just collected.
Yeah.
Oh, yeah, if you want. Mary, Tommy King, Myers, Dressler. Yes. You don't need the graph now. You can do the graph. Eric, Kelly, Kira, Brandon, Lauren, Alexis, Sid, Brooklyn, Kyle, Daniel, and Roger and Eric. Sure. Why is it what? I'm sorry. If it's less than 0.01. Yeah, if the p-value is less than the significance level, I reject. Is that what you're asking? I'm not sure if that's what you're asking. Right. Okay, now, the quiz that I'm handing out is number 2 on this. And one thing I want you to, we want to know, oh, it is a right-tail test. Never mind. So it's a right-tail test, okay? So, huh? Okay. So please put your name on this, do your work on this. I prefer you to do it on the back maybe. You can do it on our sheet of paper if you would like. I'd rather not. There's a back on it.
So you're supposed to use that?
You can use the back. And if it's going to be a big partnership, use this separate sheet of paper. Sure. I inadvertently made, I'm supposed to make 55 copies of this quiz. I made 550. So I'm going to give this quiz for the next 20 years. Who needs a Z table? When are you going to feel shame for wanting a Z table? How many times?
Only second time.
Only your second time?
Yeah.
All right.
Yeah.
I should get a big giant Z table poster and put it up in the class.
You're going to get 2 of them now, because you're not able to flip sides.
I could get, yeah, you're right. I have to get 2 posters. I mean, one there, but it'd be hard to see. Yeah, but that'd be tough. I think that's a tough angle for a lot of people. Pause. My son's surgery went well. Thanks for asking. All right. So we're going to move on. Thank you for doing that. I know we spent a lot of time on hypothesis testing, but that's because it's important and it's not easy. Okay, so I want to talk about where we're at in the course, and you guys can tell me what is next based on where we're at. There's a method, there's a systematic process we go through in this course, whether or not it's known to you. So the first thing is we talked about inferential techniques, we talked about estimation. And we said, hey, sometimes we have interval data and we're trying to measure it with a mean. So we use the sample mean to make an inference about the population mean. And we utilize this formula to produce a confidence interval. You guys recall that? The second thing was we said, well, sometimes we don't have interval data, we have nominal ordinal data, and we have to figure out a proportion, and we use the sample proportion p hat to make an inference about the population proportion, and use this formula to create a confidence interval of a proportion. We said estimation's not the only game in town for inferential techniques. Sometimes we start out with a hypothesis and we want to test that hypothesis. So we use X bar to make an inference about mu, and we used a couple formulas here. So what do you think's next? Using this logic, what are we going to do today? What do you think we're going to do today? What do you think? So we learned hypothesis testing, how to test a hypothesis test about a mean. What do you think we're going to learn today? How to speak to animals. What do you think we're going to learn today? Yes. Thank you, Anthony. We are going to learn how to test a population proportion, right? So we learn how to test a hypothesis the mean of a hypothesis. We'll learn how to test a hypothesis about the mean. Now we're going to learn how to test a hypothesis about a proportion. And what's great is just like estimation, once I learned the terminology like LCL and UCL and confidence level and confidence interval, I could apply it with a lot of different things. The same is true of hypothesis tests. We're still going to talk about rejection region. We're still going to talk about test statistics. All we really need to do this then is we need a formula. And this is the only formula we need. This formula that I'm showing you now converts p hats, sample proportions, to z values. I'm still going to set up rejection regions. I'm still going to see if my test statistic is in the rejection region, and I'll make a decision based on that value. That's all I'm going to do. So, no need to go through any theory. Let's do one. Let's see how this works. So this is actually in your book. So I'm going to go to chapter 10, and we're going to do number 7. Okay, and I'm going to project that here in a second. Number 7. This is the formula if you didn't copy that down fast enough. Okay. So let's look at number 7. It says, in some states, the law requires drivers to turn on their headlights when driving in the rain. A highway patrol officer believes that less than 1/4 of all drivers follows this rule. As a test, he randomly samples 200 cars, and in doing so, driving in the rain, and counts the number of whose headlights are turned on. He finds the number to be 41. Does the officer have enough evidence at the 10% significance level to support his belief? Okay, so we're testing a hypothesis, and we're going to start out with the same process. I want you guys to tell me what we're trying to prove for this officer. What are we trying to prove? That's going to be the alternative. What are we trying to prove? Go ahead, Daniel. What does he state? What is his hypothesis? Yes. So he believes, the state trooper or she believes, that the percentage of people that follow this rule is less than 0.25, right? So what would our null hypothesis be? Very good. P equals 0.25. So at this point, we know what kind of tell test we have. What kind of tell test do we have? It's less than, so what kind of tell test do we have? Left tail, very good. Now this one, I'm not going to set up in P world or X bar world. I'm going to go straight to Z world, and I'm going to work everything in Z world. Okay? So you're right. It is a left tail test, and I'm going to just work in Z world. So it's a left tail. Alpha, if you remember, was 10%. So accordingly, if alpha is 10%, what is going to be my rejection region? 1.28, and because it's a left tail test, what? Negative 1.28. Very good. Okay. So think about it. What I've done so far, part A, I've stated my hypotheses. Part B, I've drawn my graph. Part C, I've set up my rejection region. let's figure out where the evidence is. How did I gather evidence here? What did the state trooper do to gather evidence? Tell me where the evidence is here to test this hypothesis. What did I do? Daniel, go ahead. You're on fire, man.
That's the time the number of people driving the van with their headlights on.
And he counted how many, Daniel?
41.
Okay, so of the 200, 41 had their headlights on. So n is equal to 200, and he had 41 successes, yes? So I want p hat, though. P hat is the sample proportion. So p hat is the number of successes divided by the number I sampled. So 41 divided by 200 is 0.205, I think. Yeah, that's right. Okay, 0.205. Is that enough evidence? Well, let's think about it. I have my evidence in terms of p hat. I have my rejection region in terms of z. Can't compare apples and oranges. Inches and centimeters, pounds and stones. I need them both in the same measure. So what did I just give you a mere seconds ago that'll put it in the same measure? I gave you a formula that converts p hats to z values. And this is the formula. So I'm going to take that p hat value, that's my evidence in terms of p world, and I'm going to convert it into a z value to see if it's in there. Z is equal to p hat, which is 0.205, minus p, which at the beginning of this thing we assume it to be 0.25, divided by the square root of p, 0.25, 1 minus p, 0.25, divided by n, which is 200. You guys with me? The numerator becomes negative 0.045, and the denominator, need to do a little work. Let's see. 0.25 times 1 minus 0.25, which is 0.75, divided by my n, which is 200. And then I want to take the square root of that. And I get 0.0306. So 0.045 negative divided by 0.0306 gives me the probability that, or I'm sorry, gives me z is equal to negative 1.47. Is negative 1.47 in my rejection region? It is. I can reject the null in favor of the alternative. Does that make sense? He has enough evidence to reject the null in favor of the alternative. Does this make sense? It's in there. Same logic. Now, I'm saying, yeah, it's in there at the 10% significance level, but let's think about that. If I did this at the 5% significance level, what would my rejection region start at? Not negative 1.28, but negative 1.645. Would it be in there then? No. How about if it was 1% significance? That would be negative 2.33. No. So I want to find out exactly how much evidence I have. What value do I want to calculate out to figure out exactly how much evidence I have? The p-value. The probability that z is less than, extreme in this case is less than, because I'm doing a left tail test, z is less than negative 1.47. Well, geez, I just have to look it up on my table. Negative 1.47 tells me 0.0708 is my p-value. So in a word, how much evidence do I have? I have weak evidence. By the way, that quiz you did, I think the p-value comes out to be 0.06 something, and you get weak evidence. So At the 10% significance level, you reject. At the 5% significance level, you do not. And at the 1% significance level, you do not, right? You see how those things work together? Yes? All right, so what I'd like you guys to do is, how about doing number 8, yourself, and then we'll do it together. People going for spring break this year. Fort Lauderdale? Orlando? Golfing? Is the whole golf team going?
Yeah, we're like the whole thing on Thursday, but some of us are gonna do it. I'll be there on Sunday. So we're just gonna stay at Powell's, you know,
Yeah.
yeah, we're gonna stay at his place. He's really gonna like that. We're staying there for like 4 days.
Great.
We're out of state. Heard Fort Lauderdale's a place to go though.
See, when I was in college, I went 3 times on spring break. It was the transition when I was in college from Fort Lauderdale to Daytona. We were like, good place to be.
Yeah, we're turning to Daytona.
But our week was always early, just like yours is.
Yeah.
So Daytona, when we were in Daytona, was also bike week.
That's when we were there.
Yeah,
It's miserable.
still bike week, huh?
Yeah.
Yeah. I don't care. I don't care. If
The whole week.
Not the stereotype of whole, but I don't care. And then the one year I went to Tampa Bay because my buddy's grandmother lived there, and she had like a leather house. We stayed there, and that was kind of an odd place to go. It was still warm, but it was kind of odd. Just follow the same steps. State the hypotheses. Set the rejection region. Figure out what your evidence is. Convert your evidence to a z-value. Figure out your p-value. So most schools are on spring break the week after us, right? Like the big ones. Almost. Sure. You want that? We'll wait till Thursday. Yeah, we'll do that Thursday. You guys saw that your teams are out there for your group project, right? Thursday we'll start talking about that a little bit more.
That's what I thought. Okay, I was just gonna.
supposed to be doing 10.8 or 10.9?
10.8. All right, so let's do 10.8. It says, has the recent drop in airline passengers resulted in better on-time performance? Before the recent downturn, one airline bragged that 92% of its flights were on time. A random sample of 165 flights completed this year reveals that 153 are on time. Can we conclude the 5% significance level that the airline's on-time performance has improved? So we're going to start with, what are we trying to prove here? What is our hypothesis? What are we trying to prove? It was 92%. We want to prove it got better. So it was 92%. So getting better would be an increase, right, in this case. So that's what we're trying to prove. We're trying to prove that at the 5% significance level. So that means, what kind of tail test do we have? Because it's greater than, right? Tail test. Alpha is 5%. That means Z is, the start of our rejection region is 1.645. A, B, C, done. What evidence did we gather to try to support that claim? They sampled 165 flights. Of those 165 flights, 153 were on time. That means P hat is 153 divided by 165. So that means my sample proportion, 153 divided by 165, is 0.9273. I'll go out to 4 decimal places there. Okay. Here's the issue. My evidence is in terms of P hat. My test statistic is in terms of Z. I can't compare P hats to Z's. I have to convert the P hat to a Z value using the formula Z is equal to P hat minus P divided by the square root of P times 1 minus P divided by N. All right? Let's do it. Z is equal to P hat 0.9273 minus P 0.92 divided by the square root of P 0.92, 1 minus 0.92 divided by N, which is 165. I get 0.0073 for my numerator. My denominator, I have to do some work. 0.92 times 0.08 divided by N, which is 165. Square root of that deal, 0.0211. So I get 0.0073 divided by 0.0211, 0.35 for my Z value. 0.35 is about here. Do I have enough evidence to support their claim? I don't, right? It appears it's a little bit higher than 92%. But really, we only sampled 165 flights. I can't say this, with any kind of certainty, right? I can't support this claim with any kind of certainty because the p-value is the probability that Z is greater than 0.35. Well, if I look up 0.35 in my Z table, 0.35 in my Z table gives me 0.6368. 1 minus 0.368 is 0.3632. In a word, if I have a p-value of 36%, what I'm saying is the odds that if I make this claim I'm wrong is about 36%. In the world of statistics, if that's the evidence we have, we say we have how much evidence? None. Zero. No evidence. Okay, does this make sense? So not so hard, right? You already know how to set up rejection regions. You already know how to do those kinds of things. Now, what if we did this with Excel? Well, this is something I went over in the video, but let me show you as well. So if we were doing either of these that we just did manually with Excel, we could use that test statistics workbook that's in chapter 10. I'm going to open that thing, and just like the estimator workbook, we see multiple tabs, and one of those tabs is z-test proportion. We're testing a proportion using the z-curve. So let's do the one we did earlier, which was number 7. You remember our sample proportion was 0.205, right? That was the 41 of 200 cars. Our sample size was 200. Our hypothesized proportion was 0.25. And I think our alpha was 10%. One value I need, there's that z value we saw, negative 1.47 that we calculated out. Really all I need to look at is what? One value, the p value, 0.0708, which in a word means it's okay at 10%. We have weak evidence, right? But we don't have strong, we don't have overwhelming. Does this make sense? The one we just did, we got a sample proportion of 0.9273. Our sample size was 165. Our hypothesized portion was 0.92. And our alpha was 0.05. There's that p-value that we calculated out manually. 36%, which in a word means no evidence.
You're not getting that. You know this.
Are you using z-test proportion? Are you typing in the same number? Are you using the same thing? Because that's how computers work. Huh? I don't believe you. Z-test proportion. Sorry about that. I didn't type in 0.93 there. What did I type in? I typed in 0.9273. I don't know why this thing truncates it. It shouldn't. Right? I wanted to give the exact evidence. The other one I typed in 0.205. Right? So I'm going to use this, but let's say I do something like number 10. Okay, let's look at number 10 in your book. It says the results of an annual claimant survey of policyholders who have had a claim with State Farm Insurance Company revealed a 90% satisfaction rate. To check the accuracy of this claim, a sample of State Farm claims was asked whether they were satisfied with the quality service. Can we infer that their satisfaction rate is indeed less than 90%? So tell me what I'm trying to prove here. I'm trying to prove that P is what? Less than 90%. So I can use this, right? The hypothesized proportion is 90%. I'm going to say alpha is 5%. I need two things. I need a sample proportion and a sample size. Well, in this case, I'm going to have to go to the data file, material by chapter, chapter 10. This data is, where the hell's that? Did I not have that linked? Book Excel files, chapter 10. Here's the data, XR 10-10. And we asked them a question. We said, are you satisfied or not? 1 meant satisfied, 2 meant unsatisfied. So what do I need to do to get a sample proportion? What do I need to do to get a sample proportion? Let's do Control N. This data goes down to 178. So it looks like I sampled 177 people. How do I get a sample proportion, percentage satisfied? one thing I can do, very good, is I can do a pivot table. I need a percentage of the numbers of people that said 1. Insert, pivot table. I'm going to drag satisfied to the rows. I'm going to drag satisfied to the values. Hey, it looks like 153 out of 177 were satisfied. I could figure out p-hat by saying 153 divided by, 177, or I'll make Excel do that work for me. We've done this before. Value setting, show value as, percentage of grand total, 0.8644. Might as well copy this damn thing over so I have it in one place. If I look at test statistics, my sample proportion is 0.8644. My sample size was 177. In a word, how much evidence do I have to prove that State Farm's satisfaction rate is less than 90%? In a word, weak evidence. If I did this test at the 5% significance level, I'm saying I need strong. I don't have strong, I have weak evidence. Does this make sense? So here's what I want you to do for homework. In chapter 10, I want you to do 1 by hand, 10.9. I want you to do 2 with Excel, number 10 and number 14. Or did we just do number 10? Do number 11 and number 14. It's going to take you long. How long did I did that under a minute? I know, probably. You're going to be triple your time. That's 3 minutes. Thursday, we will kind of finish this section up. We will have some group time, talk more about the group project. I don't know. Do something. Have a great day.